Hello everybody, good evening to all. This is Anurag Roy, and today we will be looking at widgets in Flutter, specifically working with widgets. So the agenda of this session is, first of all, we're gonna look at something called states and how the types of Flutter widgets are. Some widgets that depend on states, whereas some that do not. Next, we're gonna be looking at something called widget refactoring. Hey Ayush. Yeah, so widget refactoring and how it helps, and then we're gonna be looking at something how widget trees are realized in Flutter code. So a recap of what things happened in the previous session. So we came across something called Flutter, right? So Flutter is an open source object application development framework which is heavily focused on UI and helps us in developing apps in various platforms, be it on mobile, on desktop, or on web. Flutter uses something called the Dart language. Now, Dart is an object-oriented programming language. It has sound static typing, but also has provisions for inferred typing. And syntactically, Dart is very similar to the likes of Java, JavaScript, and C++. So it is very easy to get on board. Next, we took a sneak peek of the steps in creating Flutter apps. So first, when you create a Flutter app, unless you are not focusing on test-driven development, such that you wouldn't need to write tests or the back end of the app first, generally the first line of Flutter code you will be writing is concerned with the UI. So first of all, you get the layout of the app. Next, after getting the layout of the app, you break the layout of the app into boxes, which is something you would do if you want to design an HTML web page using CSS. After breaking the layout into boxes, you would then map each of the boxes to an appropriate widget. So in this case, this is the app that we built previously in the previous session, and this is the corresponding app widget wise, I would say. So we have the top level My App here, which represents the entire app, and inside we have the scaffold widget. Now we talked about a bit about scaffold widget. It is a kind of like a template widget which provides us special parameters which helps us in implementing what you would say a special typical app controls that you would see on any app, such as you have the app bar, you have the body, you have the dryer, the thing which comes from the left or right side as you swipe, you have the bottom navigation bar, you have the floating action button, things like that. These are all provided by the app bar. Of this, we used only two of them, that is the app bar, these are all provided by the scaffold widget. So in the scaffold widget for our app, we used only two of them, the app bar and the body of the scaffold. In each of the body, that is a container, and the app bar, we have a text widget. So the app bar contains a text, same is the case for the container, which also contains a text. This who contains who or who encloses who type of relationship helps us in figuring out the widget tree. Now, widget tree is a tree-like structure, as I have shown over here, which depicts the relationship of as we build our UIs with widget of parent-child relationship. So, as you can see, we have the text which is enclosed by an app bar, or you can say app bar contains the text widget. So we have the text over here and the app bar above it. Same is the case for container, which contains a text widget. The scaffold contains an app bar and the container, and the entire thing is composes this my app widget, which encloses all of the widgets that are under it. Once you have figured out the widget tree, you then proceed to code. You create an Flutter project using this command, Flutter create project name. This is a modified version of the widget tree that we have seen in the previous slide, made to look similar to the way the code is represented, the widget tree is represented in code. So you can see the my top level my app. It encloses the entire scaffold over here. This scaffold encloses an app bar and container. Same is the case over here. And each of the app bar and container encloses a text. So this enclosing and nesting is how Flutter code, the UI is represented in Flutter code. Next, we talked about something called immutability in Flutter widgets. So if you are very familiar with imperative style programming, such is the case for Android native, suppose you want to display some different content depending on some conditions. So I have this if condition here. If this is true, then I would display something else. In Android native, you have something called my text view.text is equal to something else. You cannot do that in Flutter, as each and every widget in Flutter is immutable. What that means is, once you define the widget, any widget, you cannot change any properties of that widget. Now, how do we solve the similar problem in Flutter? Is that we have a common widget variable or reference, you might say, and to that widget reference we assign different widget objects. The widget are the same as any Dart objects, so we assign different widgets to the same reference depending on the condition. So in this case, I am assigning this widget if this condition is true, and if it is false, I am assigning some other widget. So that being said, let's get to coding. Yeah. So this is where we left off previously in the last session. It is very simple. As you can see, just displays a single text over here. So before we begin, let me just remove all comments. Okay. So I will use all the comments now. Let us try to add a button that would make the text change, right? So as we have seen in the previous slide, we can compose different UIs depending upon context, depending upon condition. So let us add a button. The problem here is the container widget that we are using here only allows a single child. That is, it only can enclose a single widget. So how can we make multiple widgets, include multiple widgets as a part of child? For that, we need to use widgets that allow multiple widgets to be its children, that is multiple childs. So for that, let me enclose the container widget once with the column widget, that is wrapping with column. Now what I did here is I think it is the same for Canvas Studio. You can have options like this, very handy options for composing your Flutter UIs. In VS Code, yeah, I think it is the same for Windows and Linux. You could press Control and the period, the dot key, and it will give you these options. I think in Canvas Studio it is Alt Enter, or it should be Alt Enter, I think, or Control or space, so something like that. I haven't used Canvas Studio for a long time, so I can surely comment upon that. So yeah, so we have included a column widget. Now what a column widget does is it takes multiple children, as you can see, in a list of widgets, and it layouts the children one on top of other vertically. So it is very similar to a linear layout in Android native, with direction as, I think it is written as vertical center gravity dot vertical, something like that. So yeah, so let me add a button, rest button. Now you will see what rest button looks like, but before, let us add a child and an on pressed. For child, it takes any widget, but typically we pass a text widget in here, which serves as the level of the button. And in on pressed, we pass a void function, that is a function that returns void. Now this function is supposed to be invoked whenever we press the button. So let us define a function over here. So the function doesn't take any parameters, it just returns void. So we can effectively define the function over here, and for changing the we will talk about we'll work with on-pressed a bit later, but first for changing the text over here, we need to as I've said, we need to assign different widget objects to the same reference. So let us create a reference over here. Thanks, Shiraj. Yeah, so we have created a common reference, and let us assign to that common reference a new widget. Let us say like that. And to display the text widget, the common reference, we need to get rid of that and pass the object that we created over here, and initially it will be this text widget that we have previously made. Let us remove the text style for now. We will add styling a bit later. Okay, for some reason my formatting is not working, so yeah. So as you can see, I have given to on-pressed a void function that does one thing, that is it assigns to grid the grid reference a new widget, right? Now turns out if you are defining a single statement in any function in Dart, you can just remove the brackets over here, give it a fat arrow, remove this colon also, and that's it. This statement is the same as the previous function that we have seen. It effectively concises the number of lines that we need to write. Hey Rajvita, and yeah, so it is the similar type of thing. Now, for the sake of modularity, what we generally do is for functions very similar to onPressed, we define it very separately from the build method. So let me do that. Handle button press. Now you can see that I have made this function private here by providing it with an underscore. So you can figure out the reason, because this function will be effectively used by this raise button alone. So it won't be used anywhere after this class. So it is a better good idea to make it private. Let me copy this. Paste it over here. We need the semicolon here again, and button press. Yeah. So that's that. Now yet another thing. As functions in Dart are first class objects, you can say you can move this and move this too. So as you have seen, we started from 3 lines of empty function, and that allows us to concise it to a single line. In the build method, we can we need to define the function separately. That's a different issue, but it makes our widget UI code a bit more concise. Now you might say, why I have omitted the brackets here. You can see the for yourself, you have the squiggly lines. So what we are doing over here is we are effectively calling this function. So this function returns void. So we are actually passing void over here to onPressed. We don't want that. For that reason, we need to pass the name of the function only. So set that, and let's load. Okay, so 2 things here. The UI, the layout of the text and the button has changed. It has shifted upwards, and the text style of the text has changed. We have not provided a text style over here. That is why it defers to some other text style. So for that, to lay out our vertically aligned widgets properly, column gives us couple of parameters. So we have the main axis alignment, we have the cross axis alignment. Well, the main axis alignment for column is the vertical axis, right? And the cross axis is the horizontal axis. We have a similar kind of logic for another widget which we call as row. So if I just replace that by row, you can see it is very similar to the column widget. The row widget, as I've said, for column widget, it layouts the widgets vertically one on top of other, whereas the row widget layouts the widgets side by side horizontally. We need the column widget in this case, so let's stick with that. And main axis alignment, we need to change the alignment of the widgets that have been laid out vertically, right? So we don't need the cross axis alignment for now. Let's use the main axis alignment. Now main axis alignment takes an ename of main axis alignment, and it gives us a couple of options over here. As you can see, we have the start, which means lay out the widgets from the beginning of the column, which is a default, as you can see over here. For spacing, we have space evenly, space between, we have space around. Let's go with space around below. As you can see, we have some spacing over here. Now, let us see what happens when we click this button. It appears that it didn't do anything, right? So let me show you that by this wonderful thing we have called the print statement. Let's print the greet variable below. As you can see, the greet variable is changing, right? But it is not being reflected in the UI. Now, why is that? Before we talk about solution, let me discuss something about states. Now, what do you mean by states? If I talk from a physics point of view, state, it can be applied for physics or thermodynamics. We are not talking about Flutter over here. So state is, in my words, in my own words, the situation. I mean the orientation of a thing in an object in a particular period of time. So state is something. Suppose if we talk about physics, so suppose we have an object in motion, right? So if we take snapshots of that object in motion as it is going through displacement, each of the snapshot we can say is a state of the object at the time at which the snapshot was taken, right? So a similar analogy is applied in UIs in Flutter, that state effectively determines the appearance of the UI. So UI is directly dependent upon state. Well, suppose we have an application that fetches data from a remote API, from a REST API. So we have state is equal to loading. If the state is loading, then we will show in the UI a circular progress indicator. The thing that's the same thing that you see in the your video buffers in YouTube. If the state has some data, then we will show the data. If the state has some error instead, we will show the error widget or some error in the UI. Even if the app doesn't have any kind of logic like that, we can think of a simple counter example. The value that the app shows, so be it 1, be it 5, be it 7, is the value of the counter itself. The counter itself is a variable which we can call as a state of the app. When we change the value of the counter, the value of the variable is changed and the UI changes accordingly. So the UI is dependent upon the counter state. Now, as Flutter has two types of widget that are dependent upon this definition in classification. So we have something called stateless widget, and we have something called stateful widget. The main difference between them is one of them, the stateless widget, does not depend on state. So whatever times you may change the state variable, the appearance and the behavior of the stateless widget will never change throughout the life cycle of the app. So it is constant. Whereas a stateful widget can change its appearance if we change the state of the variable or the value of the variable. So it has variable state. So let me go back to code and show you how it functions. So as you can see, we have been using a stateless widget the entire time. So let me first change that to stateful widget. Now Flutter, if we have installed Flutter plugins in VS Code or Android Studio, and if we hit Control and dot, just I have mentioned previously, you will get this handy option to convert any stateless widget to a stateful widget. Now stateful, by doing that, it creates two classes instead of one. Now first is the stateful widget itself. In it we have the create state function. It returns an object of the state class. Now the second, which is the second class. The second class is a subclass of the state class, as you can see, with generics of the stateful widget class. And you can see that it has the word state appended at the end. It has the word state appended at the end, and it is private. Now a state class is only needed by the stateful widget itself. So if I define this stateful widget along with the state class in a separate file, it ensures that nobody other out of that file can access the state class. That is why it is a good idea to make this state class private. So that is that. You can see that the structure of state class is very similar to stateless widget. It has the same build function and it has nothing else different, nothing else, right? So except for some additions, optional additions, I would say, the state class is very similar to a stateless widget. Now the analogy is that returning back to our object in motion example, each of the snapshots that you have taken of the object in motion, each of the snapshot is static itself. Even if the object is in motion, each of the state varying across time does not change. So it is the same for in this case. So this stateful widget can change its appearance, but each of the state objects that we see here are dependent upon each of the state variable snapshots. So for some value we have some state object, for some different value of the state variable we have some another object of the state class. So you can see that. Now as we have changed the stateful a stateless class to a stateful class, it is a good idea to not hot reload and instead restart your app by Shift R, that is capital R. It builds your app from the beginning, back from square one. As sometimes your app may crash if you try to hot reload after converting a stateful to stateless or a stateless to stateful. Now after restarting, let us see what happens. Okay, it is still not changing. Now why is that? As you can see, we have converted the stateful widget, the widget into a stateful widget, but we still need to apply the changed state to our UI. Now how do we do that? We use something called set state. Now set state function is a special function in a stateful widget class, and it does two things. First, it takes an empty function, just like we have seen on pressed over here. This empty function changes the value of the state variable. So in this case, let me put the line over here. So what this does is it takes that function which changes the state variable and it returns that function. That function changes the value of the state variable and then it triggers a rebuild. That means it asks the Flutter engine to renderer to rebuild the app from scratch so that the changed state is reflected on the UI. So let me reload again. As you can see, it has changed. Let me restart the app again. We have hello Flutter over here. If I click this button, it changes. Right? So that is how changing state in Flutter goes. Now I have made the state variable a widget here. You can give it some other data type. For example, if I convert it into something called an int, let me use the counter example again, and we initialize it to say 0. We go over here, we gave it a text widget, hello counter. This time let us give it a style. If I remember correctly, we give it as font size of 60, I think. Format, and here let us increment the counter. We don't need the print statement for now. For reload. So yeah, as you can see, we have changed the state and made its effects, made it affect the UI, right? Now, a thing to note. So we are making the entire homepage widget a stateful widget, right? So even if this app bar, this text widget is not necessarily changing, we are still rebuilding it. Same is the case for this raised button or the column for even though it is not changing, we are rebuilding it from scratch to make the state variable affect the UI. Although it may not affect our app that much, as our app is very small, but as our app goes bigger and bigger, every little bit of performance gain that we can have by restricting the rebuilds counts. So as you can see, only this text widget is changing. So what we do is we use something called widget refactoring. Now what is widget refactoring? We effectively break the widget tree and we take the small part that has been broken and make that a separate widget from the main widget. So in this case, by that handy tool, we can extract this widget. Let us give it a name of display, and that is our own separate widget. We don't need the constructor over here. We need the state variable. Let us move it over here. Don't need this. Okay, and yeah, so also don't need this, and make it a stateless widget because we are not rebuilding this anymore. Remove this pair of lines. And we are set, right? The thing is, we are trying to change the state of this widget from this widget. So it is kind of similar to, you may say, accessing a member variable of a class which we don't necessarily make it public from some other class. There are hacky ways to do this by making this state variable global and etc etc. But as we don't really do that because it gives us a headache as the app goes and goes. So instead, what we do is, let me go back to the slides. So instead, what we do is, so this is the simplified version of the widget tree. I have omitted some of the components you can see here. So we need to change the state of this widget from this widget. So making this text widget a separate widget gives us problems. So what we do is, we go up to the common ancestor of these two widgets, so that is this column, and we break the widget tree from here. So as you can see, we have the same homepage widget over here which contains the scaffold, and we broke the widget from this area and we defined it its own widget. Now this is still a problem because we are if we go by this way, we still need to label the container and the column, which we necessarily don't need to do. That gives us rise to another way we can solve this kind of problem, which we call as state management, but that is for some future session. So let us go with this because our app is very small and we don't need to worry about excessive labels that much. So let me just extract this widget. I will refactor anyway. We don't need the constructor. We need the function over here. Make it a stateful widget. Place this widget over here. Counter was here. Don't need the display widget anymore. Format. Just rename the display one widget. So press F2 in VS Code and you can rename your widget and it will be reflected across your entire project. Very handy. Yeah, so we have used widget refactoring. Let us run this. Now it may not seem very different if we talk about UI, but we have gained a little bit of performance gain by restricting the variables up to the column widget, right? So yeah, now let us try adding dryer to scaffold, just like we have seen in the wireframe that I have shown in the previous session. So to enter to add a drawer, what you would need to do is pass to dryer parameter to scaffold a drawer widget. Refresh. As you can see, we have this nice drawer over here, and swapping from the left works. Sometimes the system takes over, as my phone is Android 10. So yes, so that's that. What if you want to make the drawer appear on the other side? So in this case, we want to make the drawer appear from right to left. For that, we need to change this into end drawer. Reload, and we have the drawer on the opposite side. Now the drawer widget takes a child, just like any other widget. Let us try passing the center widget, make it a child of text. Now center widget, if you don't know, is a widget that centers the widget, centers its child widget around its content. So way easier than what is done in CSS. So there's that. Let us. I am well. Auto load. There you go. I am a drawer. Now let us add a bottom navigation bar. Now bottom navigation bar is a thing that you see on any app. That is the bottom. In the bottom, it shows you the options, the pages that you can go to. So give it a bottom navigation bar widget. Now it takes a couple of things. We first focus on something called items, which takes a list of bottom navigation bar item. Now these items represent each of the tabs that the bottom navigation bar has. So each of the options that it shows you. So in this list we can start giving it some options. In icon, we can give it an icon widget which shows an icon. Give it an object of icons class, icons.home, and it takes title. Yeah, title. Give it a text which represents the level of the tab. Let's keep it at that. Let's copy this. Add a few more. Let's add delete. Now, by the way, I'm showing this just for the sake of the demo. It has, as you have, if you have attended the previous session, the actual wireframe does not have a bottom navigation bar. So add, save that, and we have this nice bottom navigation bar over here. Now we can add a lot more, but let us keep it at 3. Now you can see that we are clicking we are tapping the bottom navigation bar tabs, but it is not being selected. Now what is happening over here? So bottom navigation bar has a couple more options, that is current index. Now what current index is, as you can see from the box, it is the index for the current active bottom navigation bar item. So it represents the index of a tab that is being clicked. So in this case, if I click this, it will give me index of 1. If I click this, it will give me an index of 2. So for that, we need to as introduce the state so that this button navigation bar can make use of it, right? So need to convert it to a stateful widget again, and let us add a state variable selected page, initialize it to 0. Over here, pass the selected page. Okay, so now we need to add an on tab. Now on tab is very similar to on post as we have seen in the rest button. It takes a function which has int as a parameter and it returns void. So this int parameter is the index that I was talking about. As we click this water navigation tabs, let me just new page print new page. Save that. Okay, even if we have converted the stateless widget to a stateful widget, it worked this time, but it may not work in your case. Just to be safe, I'm out restarting this application. Okay, we'll restart it. So as you can see over here in the console, if you look in the console, this on-tab function gives us the index of the selected tab. Now how do we make use of that? We can use set state again. By using set state, we need to just get the selected page and assign the new value so that the current index is updated to the value of the state. Save that. Auto load. It is changing now. As a tab of bottom navigation bar is typically assigned to a page, right? So how do we do that? First, let me create a list of pages that we want to show for each of the bottom navigation bar tabs. This list of pages will contain each of the pages. Now I am making it final so that we don't really need to change the number of pages, or we don't need to tweak the pages list. It will remain constant for the entire app. Let us add some pages. First of all, let me rename it F2 again, page 1. Now if you type STL, if you have the Flutter plugin installed, it will give you a ready-made stateless widget. Same is the case if you type STF, it will give you a stateful widget, and you can name your widgets very easily. So we don't need the stateful widget for now. Move that. Let us name this page 2. Container, get an alignment of center, and in here a child text widget. This is page 2. Another page. Give it an alignment. Give it a child. This is page 3. So that, go to the top, include them in this list. So we have page 1, page 2, page 3. Now to display these pages, we need to go over here in the body, and we need to display an appropriate page depending upon the state. Now if you want to access the member of any member variable that we have defined in the stateful widget from its state class, you need to access them by using the widget object. So by doing that, we can access this pages list over here. So let us reload. As you can see, we can now change pages. Cool. Okay, so now let us try adding a search button in the top. So we're going to add a search button at the top. For that, we need to go over here in app bar. The app bar has something called actions, which takes a list of widgets. Typically, we give it a list of icon buttons. Now, what is an icon button? It is a button that displays an icon that we can tap. An icon, icons dot, no, icon widget, icons dot search and on press. Now if you want to just include a button and for testing and don't really want to do anything, when you tap the button, you can pass it an empty function and it will work just fine. Reload. Okay, we have the button over here. Now the thing to notice is that the previously there was a open drawer button over here which disappeared. You can still access the drawer by swiping from the right. Let me show you. As you can see, you can still access the drawer, but the drawer button itself has disappeared. Now how do we solve that? We can add another icon button which will look like the open drawer button that we have seen earlier. Give it an icon widget, icons dot menu, and on pressed. Now to open a function, open the drawer in a Flutter app programmatically, you would need to first get access to the state of the scaffold widget. Now, why is that? The scaffold widget may display a modal dialog, a dialog which which you see with the background a bit blurry, and the modal with something very similar to an about box in the app. The about box is presented in forefront, whereas the background, whereas the content of the app is hidden behind a blur. It is darkened. In that case we cannot necessarily open the drawer. So the scaffold may also display some other page which doesn't have a drawer. So things like that. So we need to get a hold of the scaffold state. Now the way we do that is we write scaffold dot off. Now off in the function, as you could say, it gives us a state from the closest instance of this class that encloses the given context. So it takes something called context and it gives us the state of the scaffold. So let us pass the context. By the way I got hold of this context is that every build method is passed a context parameter over here for every build method, whether be it stateful or it being stateless. We have every time whenever build is called, we are passed a context widget, that context object that we can use. This so by that we can get a hold of the scaffold state. Now the scaffold state has a function called open and drawer, like that. Now before I continue, let us try to change the color of the app bar to the same as was shown in the wireframe in the previous session. Let's give it blue. Hot reload. Nothing too new here, right? Hot reload does the job pretty easily. Now you can back to the on-pressed situation of icon button. So you can see that we can kind of concise this into this form, as it is a single statement in a function. We don't need this over here format. Right. So let us load that and see what happens when I click the button. Nothing happened except that Flutter threw us an error. Let us see. Exception caught. Scaffold of called with context that does not contain a scaffold. What does this mean? We can clearly see that we have a scaffold defined over here in the widget tree, but it seems that Flutter is unable to get a hold of this scaffold state because it cannot find a scaffold. What is happening? To answer that, let us see what BuildContext really is. Now BuildContext is a handle representing the location of a widget in a widget tree. So it is because of this BuildContext we can Flutter we can visualize the layout of Flutter widgets as a tree. Context representing the parent widget are passed to the build of the children widgets. So in this code snippet over here, you can see what that means is, suppose we have this state class of a stateful widget named root, right? And in it has a build method and it gets a context. In this build method, somewhere in the code we have a child of my app, which is some other separate widget which has its own build function in which it gets a build context too. Now the thing is that this context that we are getting in this build method of my app actually represents this widget, the parent widget of this my app widget. Same is the case for this root state, the context in root state widget. So this context over here, what we are getting is representing the widget that is positioned above the root class, that is the parent of the root class. It is you can think of this as very similar to a linked list with each node having a reference to the previous node. So in this case we have this node over here, and this is the previous node reference we have that represents this node. Now as we have seen, a common use of context is passing to a function of that we have used as scaffold.off context.open envoy for opening the envoy. It we did that to get the reference, get a hold of a reference of the scaffold state which is situated above the icon button, right? So this is how typically context is used. You want suppose you want some data or reference of a widget which is situated higher up in the widget tree. So you use something called something.off context, and you will get the reference or the value in that widget or of that widget in your the widget that is lower in the widget tree. Now what is happening in our case, this is what I call the context tree. It is kind of similar to the widget tree we have for our app. You can see we have the top level app here, app widget here, which contains a material app, and in here we have the homepage app, right? So what happens is, let me go back to the code and 1 second. Yeah. So you can see we have the homepage widget. If we talk about the homepage state, which contains this entire widget tree, so it has a single build method and it is passed a single context, right? And in this build method we have scaffold and the icon button which we want to work on. So what is happening is, so as the scaffold and the icon button are part of the same widget and are in the same build method, they effectively share the same context. Now as we have discussed, context represents the widget that is above the current widget. So in this case, if we use context over this icon button, right, we get the reference to this app widget which is situated above this homepage widget. So Flutter cannot find any scaffold in this app widget, so it is giving us an error. Now how do we solve this? How do we solve this error? It gives us some solutions in the error message itself. There you go. There are several ways. Use a builder to get a context that is under the scaffold. Now, what is builder? Builder is a widget that kind of encloses a nice different context bubble around a widget that we pass it as a child. So if you use builder in our case, this builder creates a context that is under the context of this homepage widget. So this homepage widget along with the scaffold, this app bar, this body all have the same context, whereas this builder creates a different context for this icon button itself. That context is under the context of this homepage widget. Let us see how it works in action. Let us go over here and add this in a widget. Now the builder widget does not take a child, it instead takes a builder parameter. Now what builder parameter is, as you can see, it is a function that takes in a build context and returns a widget, right? So we can say we give it a context and in it return this widget. Format. So yeah, as you can see, we are passing a context to this builder, and builder creates a context for this widget and this widget alone uh, under this home page widget. So this context and this context that is used in the on-press are different because of this builder method. So being done that, let us try reloading. As you can see, it works now with no problems. All is fine, right? So is there any other way we can do this, solve this problem? There is. Let us go back to the slide. This code snippet kind of gives away the second solution to this problem. As I have said, this context and this context is different, right? So you can kind of see we're using widget refactoring over here, which is exactly the thing that we are going to do for this session. So we break the widget tree, this icon button which contains this icon button itself, into its separate widget. We break the icon button into its separate widget, and then by the magic of widget refactoring, we get a different context. So this the context of this widget and this widget will be different. Let us go back and let me extract this widget. Give it a name of pardon. You don't need the constructor over here. Don't need the builder widget either. Format. So by doing that, we make this context and this context different. Save, reload. Nothing different, right? But we used different approaches for each of the iterations. So that's that. Before we end, let me show you something called tooltip. Now, what is tooltip? Tooltip is something which you get when you press and hold any button in your app. For example, if you in WhatsApp, if you press and hold the three dot button in the top right, you will get something called more options. Yeah, right. So tooltip provides us something very similar to that. Is my exam looks, am I audible enough? Okay, looks like the issue is fixed. So yeah, so I was saying. So we have something called tooltip, which is displayed typically to make the user know that what is this button is supposed to do. We can pass it a string. Let us give it search, and over the drawer button, let us give open drawer. Say that load. As you can see, we have a tooltip in action. An added benefit is that if your user is using some assistive technology, suppose screen readers, things like that, uh, the screen reader will effectively spell out these words so that it will be easier, helpful for the specially abled users, so they can navigate around the app pretty easy. So there's that. That's it for today. So what did we see? We saw something called states, and we categorized widgets in Flutter by this criteria that some widgets depend on state, that is stateful widgets, whereas some widgets that do not depend on state, the stateless widgets. We saw how to make changes in state take effect in your UI by calling setState. We also saw a bit about widget refactoring and how it helps by restricting rebuilds to only those widgets that need the rebuild, which are changing. We saw the deal with BuildContext and how BuildContext works by working like a previous node reference of any linked list. We also saw something about the builder widget and how it helps us to get the reference of widgets that are situated higher up in the tree by segregating the widget tree, by breaking the widget tree. That is the job of widget refactoring, and by build a widget, we make a context that is different from the context of the main widget. The thing is that there are some widgets that allow this functionality, that is some widgets allow itself to be accessible to other widgets lower in the widget tree, whereas some do not. We will look into that kind of widgets in a future session. And last but not the least, we worked a bit about with Dwyer. We worked a bit about with button navigation bar, and we looked into icon button and the rest button. The code that we worked upon today, and in all code that was done in the previous sessions, are hosted in this repo. You can go over here, fork the repo, clone it, and play with the Flutter code and see for yourself the changes you can do with Flutter. So here's the link, you can go over here. And the slides for this session are available in this link if you want it. They're over here for your reference. And that's it for me. Thank you for being here today. Hopefully, if you have any further questions, you can answer. You can ask them now, or you can hit me up in Twitter or LinkedIn in this links that I have for any further queries that you might have after this session. Finally, a couple of shout outs to the outreach team who have done a marvelous job of managing the promotional stuffs in conducting this session, and the design team whose work you can see in the posters of our sessions. I really like the new poster that they have made. Yeah, so there's that. Special shout out to Faiz for coordinating with the speakers throughout this entire series, and that's it for me. Thank you.
Thank you everyone for joining us today. In the next session we will come up with something new in the React field. Debmalyada will explore the field more. We will have more tutorials, and the like this we will continue the one week React session and 1 week Flutter session. And at the end, when this Flutter FFP series ends, we will build a project. The project that Anurag has been building now, we will uh, set the code in the FSP GitHub repo, and people could contribute there. So let's keep working and keep coding. Thank you. Anurag, so Happy Singh has a few questions. If you could take them, please write the question in the comment section. Anurag will answer them.
If you have any questions, you can write them in the comments now. How to use other design system than material Flutter. So if you have, I think I mentioned this in the previous session. Let me go back to code. So we have the familiar code over here. So if you want, Flutter uses basically two kind of design systems. So it has the material design that is used in Google products, whereas we have it also uses the Cupertino design, which is the design language that is used in Apple products. So for that, you need to import the Cupertino package. Now the thing is that if you want to have your own custom design system, the material design system is the way to go because it is very customizable. You can basically tweak the end, your app layout in the pixel level if you use material. But if you want to have a iOS like approach, you can do that by importing this Cupertino package. It has some built-in the material Cupertino widgets. That is the thing I'm saying, that if you want to use custom design that is way far off than in the from the material UI, you have to use material. Let me cause material design is very customizable. If you go to material.io, it gives you various. You can see you can change almost anything in app bar. This is an example, but if you are not happy with the implementation that the material app bar has done, the Flutter team has done, you can go to the code base. Don't need this one now. You can see the entire code is open for you to explore and to customize. You can see it is the app bar is basically a stateful widget. It has a constructor. It has some, see some parameters. You can tweak the app bar by this way. Let me go to the build method. As you can see, it has the same build method that we have been using in our Flutter app. So what you can do is look at the code and experiment with it. So what you like best, what you don't, and you take parts of that code and include that in your own widget, own custom widget. The material design is very flexible in that way. So if you go to any Flutter app that has very custom design, you will see this line over here, the material package, because material, as I have said, it is very customizable in that way. But nonetheless, if you want the iOS design, you can still use this Cupertino package. It has its own sets of widgets as well. I think in the slides of the previous session, I have shown Flutter app running on Android, which looks very similar to an iOS app. You can have a look at the video of previous session. I have shown a demo of the iOS app. Any more questions?
If anybody has any more questions, please you can write it in the comment section, or if you are not able to join the session, you can also write it in the comment section. I think there are no more questions, and we should sign off. Thank you everybody for joining today. Hope to see you all again in the next session. Next session will be on the coming Friday, that is the 19th, I guess. We will have a session on Redux most probably. Dev Malyada will be taking on the session on it. So see you then. Bye.